The space aspect, I need to, there's a lot of component at Sky, so I'm going to drill down into where we're actually using it. So the top row is devices. So you've got, this is a laptop, a phone, we've got a tablet. We've got, we do support quite a lot of devices. There is the PS3, the Xbox, we've got connected TV, the Roku box, and for all those components, devices, we've got quite a few components that to serve content. So we've got the homepage, sky.com. We've got My Sky, which is where you would view your bill. We've got SkyGo, which is where you would, it's not a sales pitch at all, but we've got SkyGo where you can stream content online. We've got Now TV. If you're not a Sky subscriber, this is where you do a la carte type of monthly subscription. Sky Store to buy movie on demand. Sky Shop to become a subscriber. Sky Sports to watch sports. Sky Movie to watch movies. Sky Wi-Fi to go on the cloud. And there is many more. And what's common with all those components is there is a single Sky identity. And I'm going to drill down into what it does. So now we've just dived into the Sky identity part. The first part is the actual visible part of the journey. So this is where you sign in, sign up for an online account. You would do the security aspect, resetting your password, upgrading your account. We've got Sky Payment, where you can do online payment. We've got a security group on the floor that look for attack and bizarre behavior, because this is where getting the access to your account. We've got a single sign-on, where you go into different domain, across domain type of thing, and we provide admin tool. And what's common to all those components is there is a single identity backend, which exposes REST API to all those components and other components of Sky. I'm just drilling down now into the identity backend. This is really my area of work. So we've got a web app, typical Java web application. And there's quite a few silos here, different databases. We've got an Oracle relational database, OpenDJ, which is an LDAP store, Memcache, and Couchbase, which is why we're all here tonight to hear about. And you're going to ask me, how did we end up in something that looks a bit like a mess? But I'm going to explain it. And you're going to realize that Couchbase is actually not like the small database in this area. So this is where we have to go into the time aspect of the journey. So how did we get into the type of stack I just described? So going back in time, when this is July 2010, and here I'm going to show the type of TPS we tested the stack at. This is in 2010, and this is already an aging stack. So this was already 5 years old. So back in 2005, when you were building an identity platform, you would actually buy components off the shelf. You would go into a vendor and off we go. We've got an identity backend. So that was what OpenAM was. You would take it and it ticks a box. You've got single sign-on. You just plug it to an LDAP. That was Sun Directory Server. At that time, we did build a web app, the old one. We're going to see the new one after. And you put all your online profile into an Oracle database. And it's all, I mean, this worked, no issue. But we had to face something which is very particular at Sky. I think everyone in the room have their own problem. This is my problem, high-profile event. And I do recognize the pattern. This is a football match. This is a football match. This is the first half, and this is the second half of a football match, just separated by 1 hour. And this is, the load is quite, I mean, if I had to deal with this type of load, I would be happy. But that's not what we have. This is people going home, and then they all log in at the same time within 5 minutes. Everyone that wants to watch online, we're talking about the online, so people going into Go streaming, and they're all going to, within 5 minutes, they all enter the platform. And this, it does hurt. And we've got different levels of football match. You've got the Champions League, the Premiership, and you've got the big game, the championship type of game where everyone, and recently that was what scared us the most. But there is actually something more scary than a football match, and it's called Game of Thrones. Because Game of Thrones, in this particular event, you can miss the first 5 minutes, and you're just gonna miss the goal at most. In Game of Thrones, if you miss the first 5 minutes, maybe half of the character might be dead already. So it's even more spiky. People don't miss the start. So we started by creating alongside the existing web application or replacing. So we started building REST API, and really, as we started moving more API, the load we were able to support increased. So we were able to test the stack at 1,000 TPS. And we replaced the old LDAP, Sun LDAP, with an open source, which is called OpenDJ. And this is where we were in 2011. Couchbase didn't quite exist, I think. At that point, it was still in the... So we actually went into another NoSQL solution called Big Couch. And that was in 2011. So back in those days, NoSQL wasn't such mainstream. It was actually quite, the selling aspect, the management was interesting. So I'm going to go through the decision behind Big Couch. So Big Couch is a flavor of CouchDB. It's just an open source product where they've added the sharding aspect. So the sharding aspect is what we found in Couchbase as well, is where you actually distribute your data set into different buckets. So the more node you had, the less of the data set each node sees, which make it good at scaling. It did fit very well what we were building at that time, because we were building REST API and we were talking to the database in REST as well. And because back in the Oracle world, to serve a profile, you actually had to join quite a few tables. You've got the main table, and then you go into the services, and you join all of this, and this is where it takes time. It's interesting if you want to do queries on what services to retrieve all the people with Now TV, for example, but it's on normal operation, it's actually quite expensive. So because we were able to serve JSON profile straight from the database, we were getting more performance. So I'm going to describe the migration strategy because it's very interesting for the audience, because it does apply for not just Big Couch, it applies as well for any database. So what you do is, we're trying to migrate from Oracle here. What you do is you say, right, this is my new database. You start empty, and you start doing a lookup into it. And if you can't find what you're looking for, you get it from Oracle here, and you start writing back into the main database. And this is great because you can set it to the management and say, right, if I lose my database I've just introduced, I can still fall back into Oracle. And that worked well. In parallel to this migration, you need to have a script that go from the first user profile, number 1, to the end. So to migrate the ones that are that haven't signed in to. So that's all well. I'm going to just show you the type of data we store. This is a typical user profile. We've got a profile ID. We've got the details section. Sorry, the details section. First name, last name. When I registered, and this is all JSON, and this is same in Couchbase world. There's quite a few other parts in the profile. I'm not going through them. So that's pretty much what I'm dealing with. So the next step we did in the scaling aspect is we've actually removed this off-the-shelf component OpenAM, and we decided to build our own. And another silo here, memcache here. This is where we store our session. So when you sign in, you've got an online session. It goes into here, and we were able to go to the 4,000 TPS mark, 4,000 requests, transaction requests per second served. And with a bit of magic, between March and November, no changes in the stack. We went to 6,000 by changing a bit of the topology. And then I have to be very fair. It seems like a happy picture I'm describing. However, we had quite a few blockers at that time, so a year ago. And they were mainly because Big Couch is an aged product which is being replaced by the vendor to something else. And what we couldn't do with Big Couch is just add a new node to it. So when you, the number of nodes, you set them at the time of creation of the database. So we couldn't just say, right, we know we have to go from here to here, and it was difficult. And the other thing that was difficult was to do cross data center replication. We couldn't get it out of the product. So, which is why I'm just talking through the blocker, Couchbase was actually quite a good fit for us. We just introduced memcache. Couchbase actually took with the memcache protocol. We're using a CouchDB flavor, and this is what Couchbase is built on top of. There's still some Erlang, I believe, in the code base. And it did make sense for us. So between November last year and today, we actually took us a bit of time to go live with it. And to be very, give a fair picture, I'm going to describe the issue we were having. It's all around the view and I have to be fair, this is something we were facing with Big Couch as well. View that don't scale very well. It's inherent to, I'm going to explain why they don't scale well, but basically what you generally introduce is index document. So what makes a database very efficient at finding your data? If I've got many buckets and my data is spread across all those buckets, I can find from the document ID, let's say 1, 2, 3, 4, in which bucket the document lives. So I know from looking at the key that I just have to go to bucket number 2, and I'm going to find my profile. And if I add more nodes, I will just have to look into one bucket, and that makes the scaling aspect lovely because I can predict it. I know it's going to be constant time. Where if you have to query the same database, but this time I want to find my user based on the username, I cannot tell from the username Bob which bucket this data lives in. It's been moved into bucket number 2 based on the profile ID, nothing else. So this is why Vue are great, but they have to go through they have to query each bucket, and one of them is going to return back to you your information. So it's a Vue, we use them quite a lot, but for when you've got a football match, you don't want to be slowed down. So that's what the secondary index does. You create a small document which is indexed on this time username, and the only information it contains is the actual the main profile ID. So in tuple, I can do my hashing algorithm on Bob, and I can look up the document and say, right, the main document is got an ID 1, 2, 3, 4. And then I do the same operation, and I go from bucket number 4 to bucket number 2. So although so Vue are useful, don't get me wrong, and they're very powerful, index documents are very much predictable. I know that there is an extra call, but I know I have to deal with. As a side effect is really, since every document, each secondary index, they are going to generate quite a few of those small documents. And I checked this morning, we are over 100 million documents. So they are small, and it doesn't hurt, but you have to face it. So I have to also describe the migration strategy. I gave you a great recipe of, I'm going to say the lazy load. If you can't find it, you go down to the database underneath. So we were looking from Big Couch, and if we couldn't find it, going down to Oracle. Unfortunately, we're still relying on this behavior, which means that if we had took the same pattern, we would have gone to Couchbase, Big Couch, Oracle, which is a bit stupid. So we had to, that's the approach we took. Big Couch come with, like CouchDB, it's a change feed. So you get a stream of everything in the database and every further change. So we had a small component that was taking all those changes, and as they were moved to Couchbase, introduced the secondary index. And when we decided that we were ready, it took us some time to decide that we were ready. All we had to do is, we switched database. We had all the code ready to be able to cope with both. And in parallel, what we did is, in case we had to revert, we actually did a script which consumed the tap protocol of Couchbase to, in case we had to actually revert. And on the 16th of July 2014, we actually went live. So that's 3 months and 4 days ago. So we actually had pretty much of a success, because we didn't have to rely on some of the rollback strategy. It was smooth. And nothing to say, really. We did tested the new load. If you remember, I stopped at 6,000 TPS. We know we now can go to the 8,000 TPS, but to be fair, we know it's no longer the database is slowing us down. We actually have to scale the next bottleneck. So I'm pretty confident that we can go higher. What was interesting on the day we went live is the actual response time. This is what was Big Couch at before, and it's actually pretty fast. If you were able to read, you would see reading 25 milliseconds. So that's our response time when we serve a profile. And we went to actually down to the 5 millisecond. And this is as seen from our application, not talking to the database. So when we, so that's pretty fast and actually quite flat, which is something I like. Flat is good. You don't like to see this football match type of load. I have to ask myself, yeah, the future. So I know we're going to hear about the feature introduced in Couchbase 3. So what we are really looking for, it's been released, but we haven't tested it yet. Nico, the query language, we hope it might be a way for us to do those ad hoc query when the business wants something, they generally just want it now. They don't want to build a view. That's something we think would help us. And the in-memory XDCR, we use Memcache at the moment because it's all in-memory. It's very fast. And with the in-memory where Couchbase can pick up change and stream them into a different data center, we might be able to use it as a replacement. And the future might look from this to this. Thank you very much. Thank you.